Hello, and welcome to Tech presented by KaiZen, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KaiZen's own Chuck Sexton.
Thank you, William, and thank you everyone for joining this Tech to Tech presentation today. The topic that I'll be discussing is new cleaning technology for engine and transmission remanufacturing, specifically targeted toward aluminum parts, which is what we see mostly in this industry today, combining solvent vacuum degreasing with aqueous cleaning technology, a case study involving multiple remanufacturing sites. So typical remanufacturing process operations, and I believe I got this from Wikipedia, are clean, disassemble, inspect the parts, and repeat this until you go from an engine all the way down to the individual component parts. At the end, there's usually some sandblast or bead blast that gets done to remove the last of the carbon, and then reassembly into the remanufactured engine or transmission in this case. So we see all these different parts in engine and transmission remanufacturing, not just the transmission and engine components, but alternators, fuel rails, fuel pumps. A lot of different parts come into this operation, and most of them have pretty much the same contaminants on them: oil, grease, and burned on carbon. In the cleaning world, these are, especially the burned on carbon, three of the most difficult contaminants to remove, and they're heavy. You can see that picture in the top right. Getting that burned on carbon off is a challenge. I called a customer of ours and asked them, in a sense, just the other day for this presentation, asked to send some dirty parts photos, and you can see what's on some of these parts that are being cleaned. It's quite a variety of different contaminants. The key problems with conventional cleaning operations used today in remanufacturing operations, we see them as three key problems. Cleaning chemical costs are very high. Some of the plants we're working in around the country spend more than $800,000 per year on aqueous cleaning chemicals. Engine transmission remanufacturing requires multiple cleaning steps and multiple machines. And for someone who sells cleaning chemistry or parts cleaning equipment, walking into these plants is like walking into a candy store. I know of some plants where you can stand at one location and look around and see more than 50 washers at one time. Carbon removal resulting from the cleaning process is generally poor and requires extensive manual blasting at the end. This is very time consuming and very expensive. So the aqueous operations that are used today uh, consist of cabinet spray washers and conveyor machines, which I've kind of shown this spray operation here on these two pictures on the bottom left. That's mostly used to remove the heavy oil and grease. Then we have a series of immersion machines, vertical agitation, ultrasonic systems, often with part rotation, then used to remove the burned on carbon. And these are some parts that have been cleaned under controlled conventional process cleaning. And as you can see, there's still a fair amount of carbon left behind. And the only way to remove that carbon is by sandblasting or bead blasting. And it's most often done in a manual system like the one you see pictured here on the far left. Incomplete carbon removal results in extensive time consumed in these blasting operations. And that job is not the most favorite job in these plants. I guarantee it. The other issue is all the oil and grease that comes off in the first cleaning cycles with an aqueous cleaning process produces a lot of spent oil, oily water in particular, and you end up with a lot of wastewater being removed from these steps, and it's very costly. There's a realization that new component cleaning technology is greatly needed in remanufacturing today, and we set about some 8 years or so ago, worked with some of our equipment partners to put together what we think is a real nice solution for the challenges that are faced in cleaning in parts cleaning and remanufacturing. And this process consists mainly of two steps. The first being a vacuum degreaser to remove the heavy oil and grease, and then an aqueous cleaning with some new chemistries that are very good at removing carbon. And we've got this down now to two machines in some cases, and cleaning a lot better than we ever cleaned before. A couple slides on vacuum degreasing. This process consists generally of a 2 or 3 tank system, which holds hydrocarbon or modified alcohol solvent. The system runs under vacuum continuously, and the solvent is continuously being distilled, thereby purifying the solvent and producing a very concentrated oil waste that's generally 95% oil or higher. We even have some plants that are using that oil in other operations. The work chamber, and there's generally a single work chamber in these machines, and they incorporate, like with the aqueous machines, they incorporate part rotation, vertical agitation, spray under immersion, and ultrasonics to remove the carbon. Vacuum degreasing offers many advantages as at multiple plants. Each single vacuum degreasing machine using our METALNOX hydrocarbon solvent M6381 has replaced up to 6 aqueous parts washers, and it greatly reduced significantly reduced the amount of wastewater. If you'd like to learn more about the vacuum degreasing, please go to the KaiZen website and click on the Tech to Tech link. Insert the keyword vacuum, and you'll find 6 vacuum degreasing Tech to Tech presentations, technical presentations that we've produced in the last several years. And I think you'll learn a lot if you'd like to find out more. So the two-step cleaning process, again, using as few as 2 cleaning machines, consists of a vacuum degreasing step followed by aqueous cleaning. And again, the vacuum degreasing to remove the heavy oil and grease, the aqueous cleaning to remove carbon. Here's a good recent case study that we did. The part on the far left is an engine head, which has typical oil and grease, as you see, and we clean that part in one machine, one vacuum degreaser using a hydrocarbon solvent in about a 10 to 12-minute process. The, the slide in the middle shows that part as it comes out of that machine with virtually all of the oil and grease removed. You're still seeing carbon left behind. And then we use a very similar machine in an aqueous process using a new chemistry, M6355, which was designed specifically to be aluminum safe and remove carbon. And you can see the part on the far right, and it's hard to find carbon on that part. If you look hard, you may, but we've done, I think for 2 machines and 2 cleaning cycles, we've come a long way. The benefits of the new parts cleaning technology at multiple plants now, KaiZen METALNOX 6355 has reduced manual blasting time from 20 to 25 minutes per engine head to less than 5 minutes per head. And I know one plant where actually 2 minutes or less. And on the aqueous cleaning end of it, we've more than doubled the bath life of the conventional aqueous wash process of the conventional chemistries. Typically, that was 7 days, what we see in most plants, and we've taken it up to 20 days bath life in most plants. New vacuum degreaser aqueous two-step cleaning process accomplishes many key objectives. The lower cost for the cleaning process, improved carbon removal, improved cleaning cycle time, improved bath life for the aqueous cleaners, great reduction in manual blasting, and improvement in worker safety. And these new aqueous products are very EH&S safe. And the solvent is contained and isolated from the workers in a vacuum system. And the solvent's very safe as well, all by itself, but the workers basically isolated from the cleaning process. Frequently asked questions on this topic, I put 3 together. Is it reasonable to expect 100% carbon removal resulting from the cleaning operations alone? The answer is no, it is not. However, we've improved the cleaning operation where the conventional process was getting maybe 80% off. We're getting more than 95% off, and that has greatly reduced the time required in the bead blast or sandblast process at the end. Which type of mechanical agitation is best for carbon removal? When looking at spray and immersion, spray in air, ultrasonics is by far and away the best. And we are using both 40 kilohertz and 23 to 25 kilohertz systems and doing very well with that. When using the METALNOX cleaning process, do I need to apply a corrosion inhibitor in the final aqueous stage? If I place cast aluminum parts in non-air conditioned storage for more than 60 days? And the answer there is you do not. The aqueous cleaning products that we have developed to remove carbon also contain aluminum specific corrosion inhibitors. And when these products are used at 3% or higher, we can protect parts then placed in storage for more than 1 year, actually, in a non-air conditioned warehouse. And that is my presentation for today. Thank you for joining me.
Thank you, Chuck. And thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in this session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who'd benefit from these sessions? If the answer is yes, just go to tech2tech.kaizen.com and fill out that subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.